to begin our discussion of statistics, we need to talk about some terminology and some vocabulary so that we have the same language as we move through the semester. Let's start with just understanding what statistics is. Statistics is the science of collecting, organizing, summarizing, and analyzing information so that you can draw conclusions or answer questions. Now, when you are able to answer these questions or draw a conclusion, you also want to be able to provide some sort of measure of confidence in that conclusion that you're making. This method or this idea of statistics should sound an awful lot like the scientific method that you're already familiar with from previous science classes. And that's why it might be easy to think of statistics as a science. Now, another term we want to understand has to do with data. Data is the information that has some sort of characteristic of an individual that we want to look at. Data is what we're going to look at as far as collecting information on. Now, this data that we're looking at could be something such as cars or gender, maybe even age. But either way, whatever the data is that we're looking at, there has to be some sort of variability in the data that we want to collect. It wouldn't be any fun to look at data that never changed. So when we think about data, like height, for example, we know that height is going to change. Not everybody in a classroom is going to be the same height. Same with hair color. Nobody has this exact same hair color if we're talking about people maybe in a classroom. So the data that we're looking at is going to be some sort of characteristic that we want to observe, and it generally is going to have some sort of variability. We want to keep in mind that the goal of statistics is to be able to describe and understand the variability that we are looking at in the data that we are collecting. Now, another set of terms that we want to understand has to do with population and sample. When we think about a population is going to be everything that belongs in the group that we want to study, whereas a sample would be a subset of that population. So if I were to say all students enrolled in a MCC statistics class, I would say that that is going to be the population that I want to look at. So all students taking statistics here at MCC. Now, a subset of that population of statistics students would be students enrolled in a particular section of statistics. So for example, your section of statistics would be a subset of the overall population of all MCC statistics students. Now, how do we describe our population? That's going to come from a term called a parameter. A parameter is going to be a numerical description that we're going to use to describe our population. And when I think about parameter, I want to make sure I understand there's a little bit of alliteration going on there. Parameter describes population. They both start with the letter P. It kind of helps me understand or keep track of that idea. Next, we have a statistic. So if a parameter describes the population, then a statistic describes a sample. Once again, we have a little bit of that alliteration going on. Statistic and sample go together, just like population and parameter go together. And we'll look at a few examples in being able to identify these two items in just a moment. But one more term we want to look at before we move on has to do with a census. Now, a census is a collection from every member of the population. And if you remember, in the United States, we conduct a census, or the government conducts a census of the entire population of the United States every 10 years. So the last census that we had done was in 2020. Now, why do you suppose that they only do a census every 10 years or every decade? Hopefully you see that if I was to go out and collect information from every person in the United States, that's a pretty labor-intensive process. It's a pretty large process as well. You have to hire people In fact, they were doing that during the year 2020. The government was hiring people to work for the government to go out and collect the information locally. And so it becomes rather expensive to hire extra people to collect the data. Not only is it expensive and it is a large undertaking, but it is time consuming as well. So generally, census is not our normal way of collecting information on collecting data. Instead, we look at things like population and sample in order to collect data. Let's take a moment and look at an example together where we are going to try and identify parameters and statistics. So here is an example. It says, suppose that the percentage of all students on your campus who own a car is 48.2%. And what I want to know is the 48.2% that's listed there, which is a numerical summary, is this describing a parameter? Is it describing a population, or is it describing a sample? So we need to ask ourselves, 48.2% is describing all students on campus. So all of the students on campus that own the car is who we are looking at. And since I'm talking about all students, I have to therefore be talking about a population. Since we're looking at a population, that means that the 48.2% is a parameter. And as it says here, this is a numerical summary. It is a numerical value that we are using to describe the population. The second example says, suppose that a sample of 100 students is obtained, and from this sample we find 46% own a car. So that 46%, we need to determine, is that 46% a statistic describing the sample, or is it a parameter describing the population? Hopefully you can see that in the sentence, we are looking at a sample, kind of a giveaway there, of 100 students saying that they own a car. Now, so the 100 students becomes a statistic that is describing our sample. This one is kind of straightforward because I'm using the word sample in the sentence, in fact, twice, so it should give you a clue that we're talking about a statistic, because a statistic describes a sample. But I could have given you a sentence that said something like, in a survey of 100 students, 46% own a car. 46% would still be the statistic describing the sample obtained from the survey. So you might have to use a little bit of context clues in the reading to understand if you're looking at a sample. Most often, anytime we have a numerical number or a size of people that we're looking at, for lack of a better term here, anytime we have a definitive size, like in this case 100 students, you're typically talking about a sample. And then finally, the last set of terms that I want to discuss with you are descriptive and inferential statistics. Descriptive statistics is what we're going to use to describe our data from our sample. So in other words, after I have collected my data, I need to organize it and summarize it. And I'm going to do that using numerical summaries, tables, and graphs. So in the previous slide, when we were talking about 46% of the students who owned a car, that's considered a descriptive statistic. Same as 48.2% of all the students who own a car, that again is a numerical summary, which we consider a descriptive statistic. The other type of statistics that we're going to look at towards the latter part of this course is what's called inferential statistics. And in inferential statistics, we take that information that we have collected from the descriptive part, and we are able to make some sort of inference onto the larger population, and we do that with some sort of reliability for the result. So we have descriptive statistics, which we are going to use during the first, say, third of the class, and then we will talk about inferential statistics during the last third of the class.